Hello everyone, this is group 59. Our project topic is photo remediation by indoor plants. I'm the team leader Zhe.
Hi, I'm Ling Xuan.
Hi, I'm Sylvia.
Hi, I'm Li Danzhao.
Do you know have the 7 million global deaths are associated with air pollution exposure? One way to mitigate the air pollution is by photo remediation, which uses the nature of plants to absorb the toxic contaminants and purify the air. As people spend 90% of time inside, the indoor air quality has rising attention and also brought our interest to quantify this ability. We studied the effect of active green wall to remove the PM2.5 and the formaldehyde created by cooking. Our project developed a real-life case based on a group-based house from the picture on the right. For preoccupied house, PM2.5 and the formaldehyde normally remain at a global level, compressing to the effect of cooking. So our focus is to simulate the contaminants concentration level by cooking and remove the power of active green wall under typical Melbourne weather condition. So next part is methodology. The Ling Xuan will introduce it to you guys.
This is a simple illustration of us repeating the experiment using CONTEMP. CONTEMP is a multi-zone indoor air quality and ventilation analysis computer program designed to determine airflow, contaminant concentration, and human exposure. We therefore can simulate under the real weather condition to output the pollutant concentration over time. Due to the current situation, it has now become the best practice for us. To demonstrate our understanding of the theory, we repeated the experiments in the literature and able to acquire the same result to consolidate our model for the next step. Then we developed a more complex model based on the real residential house. We decided to locate a green wall in the living room area and pollutants are generated from the kitchen. Siwen will then provide results discussion.
For our result, we only present the result for formaldehyde. Will PM2.5 follow the similar trend? First of all, we simulate the real condition, which all doors and windows fully closed, and we can find that when with the same surrounding condition, active green wall can effectively reduce the formaldehyde concentration in the living room. For the natural condition, the climbing of those concentrations mainly controlled by the cooking schedule together with the outside wind condition. While for the active green wall condition, its formaldehyde concentration can always be stay at a low level. We also did the analysis for different rooms in this house. It also can be seen that with the same source, compared with the other two bedrooms without green wall, the living room with green wall will definitely has a much lower formaldehyde concentration. And for the other part, we also studied different ventilation conditions in this house, and we compare their result with the previous effect of green wall. Then Eden will detailedly talk about this part.
Like what Siwen said, we have found that airflow has obvious impacts on these results. We compare the effect from ventilation and active green wall by plotting the concentration change in different conditions. It can be seen from green line. With all windows open, we can see a significant reduce of pollutant. Similar performance with green wall, and some part is better than green wall. While there are only part of windows open, some can still reduce the pollutant. However, ventilation also has negative effects as shown. We also did same analysis for PM2.5 and basically got similar statements. And since airflow has a clear impact, weather condition, especially wind direction and speed, can be further studied, and the seasonality analysis can also be considered. For idea to extend this project, there is a CFD simulation on CONTEMP which can perform the 3D concentration in the room to fill the gaps in our project. That's all of our presentation. If you have questions, please contact us.